Oh, yeah?
Yeah.
Okay, good. Just wait to see if Sujit comes on. Have you been doing the deep unsupervised group at all?
Yes. But it's so they're doing normalized flows. Actually, I had to leave halfway last time because it's Saturdays. I don't know. My wife puts restrictions.
Yeah, of course.
Yeah. But it's really interesting. So I think it's worth listening to the recordings because the guy who is leading normalized flows, he's the one who was doing the machine learning class. The
Pipes? No.
No, he was doing a couple of chapters in machine learning and TensorFlow. So scikit-learn and TensorFlow, and he's really like he has his own way of presenting it. So it's like much better than the lectures. Like as far as like way to understand why things are done this way.
Yeah, that's pretty unusual to have someone leading a group like that that actually is, has pedagogy, let's put it that way. Yeah. Usually most of the value comes out of the group talking about it, not the person presenting it in a lot of these. That sounds good. What's the normalized flow? So is that sort of just one of the basic unsupervised, like sort of the foundational piece of unsupervised deep learning? Or what's the big picture there of that class?
So again, I like didn't follow the whole I still need to try to actually like do it myself, but my kind of main take on it's a very interesting idea for distribution, for like modeling distributions. So normally what people try to do, and that's besides like deep learning, it's just neural networks happens to be a mechanism that everybody uses now, but typically what you try to do, you try to model unknown distributions, and you try to get to it like as close as possible through like various methods. Like typical method is like a variational method where you have a known distribution which is somewhat similar to distribution you're trying to achieve, and then you sort of then you adjust and you like so the answers you're seeking would be like so you adjust distribution from what you get from like known distribution to to unknown, but the normalized flow is different. You actually what you try to model basically you map a known distribution from known distribution, but it doesn't have to be similar. It's not trying to start with a distribution that's similar to unknown. You start with a distribution that's really, I think, like any Gaussian or or uniform, and what you model is this mapping function, and this mapping function has to be monotonous, it has to be reversible, and it basically the gradient of that mapping function basically tells you like the important parts of the distribution.
So would you say that the idea is you sort of to some extent are starting with a arbitrary, I guess the Gaussian or whatever, like sort of a very as normal a distribution as you get, and then the mapping that gives you something to do your gradient against, right? So when you're doing your mapping function must be looking at the difference between your Gaussian distribution and your distribution. Is that sort of roughly the idea?
Yeah, and I think you start with normalized typically.
Okay. Okay, so it's basically that does sound like you end up with I mean, what's the output from that? Is it like clustering or LSI? I mean, latent semantics or?
Oh, you get distribution, and then on that distribution you can calculate whatever, whatever the you can try, like, do the other thing. You can do like generation, or you can do whatever you want, like with other methods.
Yeah. Oh, you mean it just becomes an embedding space? Well, not a word embedding space, but it becomes a vector space.
It's a it's a function, right? So then you can use it it's like as any other like generative methods, or you can use it to it's a cluster. You can use it in anything.
Yeah. Okay, so it's like going beyond the self-supervised, and it's just completely unsupervised. That's why it's deep unsupervised, and it's a way of training. I'll look into that. So is that the main sort of focus at this point in that group?
It's
normalized
so
flows?
it's unclear. So it's really interesting. Like, I think you pointed me to the interview with a climate scientist, and they use it to
What was that called again?
Level. It's downscaling.
No, but they were also using an autoencoder. That's where I started researching autoencoders, which is a type of encoder decoder.
Yeah, but I think they actually use. And I haven't I only listened to the interview. I haven't looked at the small scientific presentations or papers. But I think what she was saying is that their main tool is normalized flows. And somebody's trying other unsupervised methods like GANs, but.
Right, so that was. I thought of you immediately because you're the guy I heard about downsampling of satellite data, and that's what they were doing, using an unsupervised method. So okay.
I still haven't
found. So they're using normalized flows too.
I think they're using normalized flow, but I just listened to the TWIML interview. I didn't look at the presentation because I keep thinking we can. It's a really cool technique, and but it's not really applicable to what we're doing at work, because as for climate data, because we our scale is much higher,
So Sujit, I was just open-ended asking about the unsupervised Slack group.
Oh, I see.
Sort of just sort of in general what they're it's sort of covering, and we were talking about normalized flows a little bit, which I knew nothing about, but Yuri was explaining that to me. You're sort of participating in that too, aren't you?
Yes, I am.
What's sort of the main gist of that? What you guys have covered? Is it mainly around normalized flows, or are there other?
So the first group of models we covered was autoregressive models. And last 2 weeks, we have been covering normalized flows, or flow models, basically, one of which is normalized flows. I don't have a very good idea of normalized flows, except that you define somehow a transformation that is reversible from source to destination. So you're able to then move from X to Y and from Y to X, right? So yeah,
and you're right, Yuri. I remember her talking about in that podcast about the satellite data. That's exactly what she was talking about. Was the reversible transformations.
But it seems like, at least to me, it seems like reversible transformations are not easy to come by. So you would need to do a considerable amount of work to find such transformations, or modify your data to work with such transformations. But I'm still learning, so we'll see. Maybe I'll do a Fauci, and in the light of new knowledge, I will change my tune. So yeah.
Yeah. Reversible transformation. It's not like back translation. That's ridiculous. It's completely different.
No, that's different. Yeah, that's different.
But it's still, it's that's how you're learning, right? It's by going back and forth from until the space can be reversed. That's your basic forcing factor for your, your optimization.
Right. The person who is running the class, the last two for the flow models, he got some really awesome slides he created, and he went kind of from first principles. He talked about CDFs, like cumulative frequency distributions, right? And how because that is monotonically increasing, you can now do a invertible map, right, from X to Y, from the X-axis to the Y-axis of the CDF. So that was quite nice, and he's done quite a lot of work, and I think the slides are available in the channel. You should take a look at them; those are really good.
I have, I can share just a little bit on. I caught myself up on Streamlit, and my God, I think I haven't used it for 6 months, and there's just so much new in there. There's a couple key things about it that I just read through the documentation. I'm just beginning to use it, but I can do that. But rather than doing that, at least at first, I thought maybe we just because I could do that next time as well, I guess. Just see where everyone's at, and maybe we'll just start. Yuri, what you got going on? Do you have any questions or any progressions in any of the various things we've talked about?
Actually, can I go later? Actually, I have to answer something at work right now.
Okay.
Yeah, sure. So what's going on with you, Sujit? I know you were stuck with the GCP stuff, with hitting AWS from GCP. Did you ever figure that out?
No, we didn't. We ultimately decided we weren't going to do it. So essentially, what we were doing, right? We were trying to fine-tune a CLIP model with satellite data, or not satellite data, aerial photograph data, right? Remote sensing kind of data, and so we had this functional map of the world that Yuri pointed us to. Unfortunately, the data is in AWS, and what we wanted to do was doing a caption model that complemented our model that would take images and produce captions out of it, right? So the way we thought we would do it is because CLIP kind of pushes the captions and the image in the same point in embedding space around close to each other, that we would take the caption encodings, feed them as input to a GPT-2, and get the output, right, to get it to reproduce the caption, basically. And that was a training regime. Unfortunately, it didn't work out too well with the limited data we had. So we wanted to, add more data with the functional map of the world data, but we couldn't. So, but in any case, that didn't work out too well, so we stopped doing it. So that was what happened with that. We did, so there were 48 submissions to that contest, and we made it in the top 15. So, that is nice. So there will be another judging on Monday, and we would, that would be for the first 3 positions. So in any case, so we made it in the top 15. I didn't hope to get here, so I don't hope to get into the top 3. So it's fine. It's good. Whatever came up. Yeah. So.
Yeah, that's great.
Yeah.
And sounds like a really robust exercise for everyone. A lot of times those hackathons can be, a little underwhelming.
Yes.
Like
yes. Yeah.
That one was not. That was pretty good.
Yes. Well, to some extent, our the problem we chose was probably a little simple, but we did, based on our experiments, we did the fine tuning did increase our performance significantly over baseline. So what we did with baseline was we took our test set, the RISC-CD, the data set we were using, their test set, and we ran it against a untrained or pre-trained clip model, which is supposed to do zero-shot learning, right? So, and we took the we took the case, the score, how many it got right at certain point. So our baseline score k at 1 was around 0.5, and our best model was, I think, 0.88, and the second best was 0.86 or something. So significant, like 30% rise, right? So it's not bad.
That's probably not a bad score for a multimodal problem like that, right? Or is it a little more difficult?
Yeah.
So, I mean, that's at 0.86 definitely puts it in the world of useful.
Yes, exactly.
In the practical world.
Yeah. And the demo that we built, we actually based it on the test data itself, and that was also quite nice. We also tried some additional outside data, and I don't know if I showed you the demo. Did I show you guys the demo?
Yeah, you did last time, right at the end.
With the, was it like, did you see the third one? Because the third one was, Arto suggested this. I don't know. Let me show you, and if you have seen it, you stop me, right?
Yeah.
Because that was, it was Arto's idea. It was not mine, but it was like a really, I thought it was a good idea, and so did the evaluator. So that was what, I.
Yeah, go ahead, take your time, get yourself set up, and share your screen.
It's here. Hang on, it's there already. I have to start looking at it, post the evaluation comments and so forth. So you see it, right? There's text-to-image retrieval in the center.
Yeah, I see the three. I'm just trying to reorient myself. Image to image, and then feature to image.
Yeah, I think
the first two, right?
Yes. So the feature to image is this. So essentially, if you provide a aerial photograph such as this one, this is Saint Tropez, by the way. It looks very nice from the top. And then you try to, basically the idea is to find features in the image, right? So let's say you have this feature and you say, I want to look at all the ports, right? So I say port, and then I find.
Oh, wait. So you're talking feature as in not like shapes and things, but actually the word. You can put in the word.
Yes.
Wow.
A descriptive feature, right? So, and then what happens is that it breaks it up and finds that, this portion of the image is ranked the most highly in terms of, for my port. And this is the second one, both of which contain a lot of, like port-like features, right? So similarly, if I do beach, I will get the left and the top and bottom on the left, right?
Yeah, do it.
Okay, I'll show you this.
It's beautiful. I mean, it's cool. The idea is amazing.
I'll make it a little wider, I think. Let's see. Anyway, so if I do beach, you'll see this is ranked 1, and this is ranked 2, right? Actually, let me refresh this, and I'm thinking that it should, because I typically make it very narrow. No, okay.
Yeah, there's a wide view for Streamlit and a narrow view too that you can use in the configurations. So usually when I'm on the narrow view, I keep it narrow like you've got it.
Okay.
Okay, so beach.
So beach.
Well, show them, what you really need to do is have two open and show them side by side. But yeah, I see how it's stressing that. Well, also, will it work with a larger area picture that maybe is like a whole city?
Whole city.
Not a whole city, but like zoom out a little bit.
I've got more zoomed out stuff. So one of them I've got is this one. Let's see, multi-story building. And there's no beach in here, but you can see a road. No. So it's.
Do you think you proved the ability to use Clip to do this?
I think so, to some extent, right? So this one ranks 1. It does have a road in the middle. There is a nicer road here, which is ranked 3. So,
I have a question. What's the full image? Show me the full image.
Here. So this is the actual road, this one. Oh, that is the example image. The one here is example image. This is the actual image that I selected.
That's the multi-story storied building.jpg.
Yes.
And below that, we're seeing how it focuses on the road, the first one.
Yeah, this is the input image, right?
Yeah.
This whole thing is the input image. Now.
Yeah, you mean the one that's captioned, input image?
Yes, exactly.
Okay,
right.
I got it.
Yeah, and these are the roads here. So it actually got it right. I'm wrong. So you see this one with the yellow strip, right? This corresponds to this one, right? So this and this, it got rank 1 and 2, which is correct. And this one looks like a road, but it's actually a pathway inside, right? So this is inside the building. It's not a road. So let's call it a pathway and see what it did.
Wow, that would be a fine distinction.
Yeah, we'll see.
It does. It puts it first, right? Is that different than
no. Rank 1. No, it doesn't actually.
I mean, I just think of this.
How do you create batches? Like, how do you pick what batches to look
I
at?
just cut it up into 6 pieces. Actually, so what I do is I take the input, I resize it with cropping to 600 by 800, and then I cut it up into 6 pieces of 224 each. So 224 by 224. Sorry. I first resize it to 600 by 800 with cropping, and no, sorry.
By cropping, do you mean you put a buffer? I mean, a edge, white space on the edging?
Yes, unfortunately. Okay. Well, no, I actually destroy stuff. So that is. Let me show you this. This is actually a bad thing I've been doing.
But you're doing like you do with convolutions. You put the bound.
No, I'm actually destroying. I'm destroying data. So if you look at this point, right, this tree here, you won't find the tree here, right? So see this, right? So the tree should have been somewhere here. But what happened is when I cropped, I lost this bit, right? For some reason, I don't see the tree here. And it's very annoying now that, let me try opening it up fully. Maybe this, now it's better.
You're pre-chunking up the image just based on some sort of cropping heuristic.
Yes, exactly.
And then when you're searching, you're finding those are actual images, the cropped images in your model that you're retrieving.
Yes, exactly. Well, no, I'm cropping it inline. So I'm taking this, I'm cutting it up into 6 pieces, or pieces of 224 by 224 each, because that's what the model will take.
So by you saying inline, you mean you're cropping it at query time?
Yes.
Yuri, did that kind of answer? Was that kind of what you were asking?
Yeah.
So you're cropping at input time. You're getting the embedding or the vector representation or the tensor, right, for each of the cropped images, and then you're finding out where it is in that space, vector space, and then you're or which one's closer to the word.
Yeah, Clip allows you to do one image and multiple captions, or multiple images and one caption, right, and gives you a comparative probability. So these are so I took 6 images, right?
Yeah.
And I said, okay, give me the caption is an aerial photograph of a beach, right? So I just plug in the word, whatever the word here is, I plug in the word into an aerial photograph of a, right? So, and then I basically run this batch of images that I just chopped up through Clip or through my fine-tuned version of Clip, and I get the results. And that's what I report.
Yeah, I guess that's what I was. Yeah. That's interesting.
So were you thinking of, for like usage, do you think this is kind of an alternative to those feature maps and activation maps?
No, I was, in terms of application, I think one possibility could be Google Maps, right? So instead of saying you want to go to this address, you could say, a park in Danville, right? across from the school building. So it should be able to.
Isn't it a little like, I mean, this is way abstract. Is it a little like Squad?
Kind of,
it's really like you're asking a question, like you just said.
Yes,
Where is the port in this image?
Yeah, exactly. Yeah.
It's basically Where's Waldo?
Exactly.
You could actually do that as your proof. That would probably go viral.
Yeah. So anyway, so that was our thing. So there's still so the evaluators have given some feedback, and one of them is that they want uploads, which is so again this is now goes back to Streamlit. So Streamlit file uploader, the current version works fine, but the version they have on the Hugging Face Spaces, and which they cannot or will not change for at this point because it's in beta and they don't want to mess with things, has a bug in file uploader. So the moment you upload, it will actually crash, right? And so that's the problem with file upload. So I can't.
Are you talking about with Streamlit specifically? You're talking
yes. Streamlit 0.7. It's up at 0.8 now. So,
yeah, no, it's actually 8.5 as of yesterday.
Yeah, right.
And those decimal places matter huge.
Yes, it's a very fast-moving project, right?
Yeah. Oh, those guys have the best documentation I've ever seen. I mean, Jesus, and their improvements are like spot on. They're amazing. Okay, so you guys are getting screwed by an old version of Streamlit. Yeah.
So anyway, so that's the reason I basically did the canned images that you can look at. So it's what it is. But they have given us some feedback about the model card. They want more information in there, so we are going to work on that. And instead of having these like copy paste kind of things that I have here in my image, right? So in my text to image and my image to image, I basically put in, let me show you that again. Sorry, I took it out. Just quickly share again. Oh, damn it. Sorry. Let me get this back. Okay. So what I did here was that I suggested, things that they could try out. So, just to get people started. So I put in, these things here, right? Some suggested queries to start you off. So some of the people that were, the other demos that I've seen, they actually have these as buttons. So you can, click the button and the query would start, or you could fill in a text query, right? So I plan to do that bit at least to make it a little more attractive to, folks. So that's.
Yeah.
Yeah.
Are you going to be able to thought leader monetize it? I mean, like write a blog, or do you plan to do something with what you've?
Yeah, monetize. I don't know. I mean, this is more.
I don't mean make money. I just mean, a lot of times you turn your learnings into a Git repo or a blog or I don't know what, or Twitter. Or you have any plans for this?
Yes, of course. I will write a blog on it. This is a pretty significant piece of work that I've done, or I have participated in. Arto did most of the training, so I cannot claim credit for that. But I did the evaluation and I did the image augmentation and the demo. So, Gautam did the text augmentation, which was actually quite cool. He did this back translation thing with multiple Marian transformers. The Marian is the multi-language family of transformers. So essentially, we beefed up the captions with that. So, if you wanted additional captions, you just send it to a language and back. You want another one, send it to another language and back, right? So it was that was the strategy that we used there.
Is Gautam in school now? Grad school?
Could be in grad school. I thought he was going to Germany somewhere, right? Germany or Italy.
Yeah. Yeah, didn't he get into a program?
Both.
What was that?
Oh, sorry, I unplugged. I
Okay.
muted the wrong thing. The wrong Yuri. I think the program was start in Vienna or Czechoslovakia,
Yes.
and then go to University of Turin, maybe.
Trente, I think, right?
Trente.
Yeah.
Maybe he's starting in the fall.
Could be, yeah.
Because my guess is once he's starting, unless he's like superhuman, he's probably not going to be doing too much of this.
Right, yeah. But the thing is, if you are working or if you are studying, you actually get a lot more, cool ideas. You may not be able to do much with it, but you are suddenly exposed to viewpoints from the other side, right? The academic side, and I think that's a very cool idea. Every time I do one of these courses, I learn so much. Of course, not that I do anything with them, but I learn a lot of ideas.
Are you judged at work at all based on your blogging and sort of that you've covered areas and sort of published on them?
It was used to be that way, but now I don't think they take as much, put as much emphasis. We are now more into, so ever since our new CEO came in, she is very much customer focused, and her success is also very much, based on customer focus. So her formula is basically customer focused. The previous CEO was more academic, so he liked that kind of thing. So it kind of changes our, the performance criteria we're judged on changes basically based on the company culture, which also changes based on the CEO. So,
yeah. All right. So, Yuri, you have anything you want to cover or talk about?
Not much. I'm working on mappings. It's exciting. Maybe I can show something next time. Because I'm starting to visualize them, so they're kind of fun to look at now.
You mean between vocabulary?
Yeah, basically, mapping between the ontologies, essentially.
Yeah, that would be interesting to see for sure.
Oh, I have one question for Sujit. So I saw a video from the sentence transformers from this effort, but it was more like instruction. It wasn't like a video for like a general consumers. I guess it was just a
how to train, right?
Yeah. Do you know if they've been like public? I saw them because Niels published it himself. But do you know if like all your reports are going to be published?
Oh, everybody's reports are going to be, they're all public, or they, at least I think they are all public. Ours, we did a little differently. We started with a public GitHub, and then we submitted a model card, which I think may be public at the moment or may not be, but it will be, like, once the event is over, they're all going to get public. Other people started with Hugging Faces built in, or that is the recommended approach. So essentially you start by creating a space for yourself, then working in that space, and then they have made it very easy for you to publish your models from your Hugging Face space, right? So a lot of people went that route, which meant that your GitHub is kind of under Hugging Face. It's not like a general GitHub, even your clone, right? So you say github.com and then blah blah blah, and then it's your name, and then it's your repo name, right? Here there is a huggingface.com/github and so on. So I think, I don't remember if so, files and I don't remember the repo name. Wait, I think I have it written down here. So see, projects, HF, notes, right? Notes. Come on. Yeah, I don't have notes. Where is my notes? HF. Text one transformers. It's clip, maybe clip. Yes, notes. So it's so my demo area. I don't know if you'll be able to see it, but try it and see if you can. So this is the repo URL. So can you see, check if you can git clone it?
No.
Okay. So
Spaces are currently in private beta while we're running.
yes. Okay. There you go. So I think the people who use Spaces to build their code. So I just use Spaces to build my demo because that's the only one that's, they provided that. But the people who build Spaces to build their code will also have the same issue. But I can check
So
if Nils's team actually made it. I'm pretty sure they did. I mean, made the top 20.
So Spaces is really just a Hugging Face place to show off or just put, projects.
Yes.
It's kind of like the project space using transformers.
Yeah, and they have made it easy for doing a lot of the standard things that you would do with Hugging Face stuff, right? If you were to fine tune a model and train it and stuff like that.
Well, I mean, I'm looking at Spaces now. Discover amazing ML apps made by the community, right?
Yes.
It's in beta. You have to sign up for beta to get access to it. So you could probably sign up for beta and probably get access to it.
Yeah.
Right. And then, but it's really just like made with ML kind of.
Mm-hmm. Yes.
Used to be. Is that what it is? It's because it looks like projects built on transformers. Right.
Yep. Oh, I don't
Good.
see it though.
Don't
Sentence
see what?
bird. Sentence bird. Let me look for sentence bird.
I see Flax sentence embedding. Just search on sentence in the huggingface.co/spaces.
Flax community. Fine-tuning a T5 model for sentence splitting in English. I'm actually looking at, yeah.
There's two sentence projects, Sentence Simplifier and Sentence Embeddings. Flax Sentence Embeddings.
Oh, sentence embedding. So they are there. Sorry, my bad. Yeah, they are there. And
yeah, it's just you can't get it. But I think what does it take to sign up for beta? You just sign up for it and then you get access. I don't know.
Yeah, you have to. You have to line up, I think. So there is.
Okay.
I don't know how to run this, but let's try it. I can share while we do it. So here is Nils's project or his demo, right? So okay. So demo using flex sentence transformers. 3 general purpose.
Is it all Streamlit based?
They have Grad.io as well.
So Spaces, what they're doing, that's such a good idea. I've never heard of Grad.io, but that's such a good idea to have a project space that gives you somewhere to work in like that.
Right, yeah. Okay, sentence similarity. Please enter here the main text you want to compare. How many texts you want to compare with? Okay, so shall I just, Yuri, you have any suggestions? It needs 3 sentences which are about the same or close to each other or not, right? Okay, I can try something easy, right? Maybe. Humpty, well, not Humpty. I like the movie Inception. Inception was a nice movie.
This is basically sentence similarity. Yep.
I think so. Yeah. Yeah.
Yeah. So you're just comparing those two, 1 and 2, to the original.
Yeah. Yeah.
Yeah. I don't know if it'll work with single words though. But go ahead and scroll down a little. I can't see. the
Yeah.
results.
That's pretty bad, right?
It's actually pretty bad. Yeah. Let's see asymmetric QA. I don't know. I mean, maybe I got wrong. Wait. So they have different. Just to
Different models to compare.
Yeah. Okay. Oh, we can compare.
Do all three of them. It's a multi-select.
Yeah. Tell me the similarity. Ensemble, maybe. Ah, there it is. 594. Even so, it's not very good.
Nope.
Let's see if
yeah, but maybe that's actually makes sense because it's not really doing it's not trained for sentiment, right? It's
do broader.
It's really trained for like similar words.
Do something like we'll do something like instead of movies, cars. You know what I mean? Like a completely different subject area.
Okay.
Right, Yuri? Something like that.
Yeah, but usually like one thing is like it worked okay for like negation. That's why we actually like picked it because basically like the general
now make a sentence on cars and then make a sentence on like movies or something completely separate. You know what I mean? Like it should be distinguished across domains. Is that Yuri? Is that I didn't quite get what you were saying.
Oh no. So like we can do this, but yeah. So negation is really like the one thing that works well in sentence embeddings.
What does that mean? In this context,
like so it's like two things that, and one will say not, it should separate it like enough.
Okay, how is this? 1.2.
So it's a better differential.
Yes. Well, they're talking about two different subjects, so yeah, I think definitely that's. Yuri, you have a example we can use?
Yes, let's do organic corn. And then let's do the other one. The first one would be maize.
Okay.
And the other would be
cauliflower.
Not organic
okay.
corn.
Non-organic, maybe?
Non-organic corn.
Okay. 2.6. It's actually, there is a bigger differential, I think.
So the first one is, wait, the first one is maize, right? That's actually lower. It should be, oh, no.
Negation's not
Oh,
working.
actually let's change the first one to corn.
First one to corn, okay. This one?
Yeah, just say corn.
What's more similar? Maize, obviously.
Maize is corn, so it's really close. It's really not sentence, but it's a word similarity. But it should.
2 and 8.
Wrong. You got it backwards. Oh no. You see the third one obviously is the best, and it's been that way the whole time. I think MPNet does distinguish between those, and it's a subtle distinction, but you'd expect it to be kind of.
Yeah.
You just found it. Is that what you were looking for, Yuri?
Oh yeah. So what we basically do fine tuning on top of SBERT, and we like separate it even more. But
well, it shows promise for doing what you did, and you already did it. No, it works.
But it's interesting. So I actually never compared corn to maize in like default. But we have our own aliases, but I don't think we ever plugged them into our similarities. So we rely on like a general training to know that corn is maize, and we should.
Okay. So this maybe has made it worse. This training.
So we actually but it kind of tells me that we really should plug our aliases also.
Right. Yeah.
It'd be interesting if you could. Not back test, but I'm kind of calling it that, your aliases, and identify ones. It would be interesting if it surfaces ones that are bad or weak. I don't know if you have data quality issues, but right.
Everybody has a data quality.
Yeah, no shit. Even in my frickin' brain, yeah, I'm a walking data quality issue.
See, he's got two other things. Let's see what they are. What is the weather like in Paris? Weather in Berlin? I have 3 brothers. Okay, so this actually might.
What is this doing?
So he's saying you can compare the answer likeness of a given query with answer candidates of your choice. In the background, we'll create embedding for each answer, and then cosine similarity between the answer and the query sentence in the others. Okay, so essentially, how
QA,
relevant is an answer,
ranking.
right? Yeah.
Yeah.
I have 3
QA
brothers.
rank.
Should
So you could do like a squad QA, and then all the results that come back from maybe different pieces of text, you could from different documents, you could then rank them. So it's a ranking, re-ranking, or whatever.
How's that?
It's funny, yeah.
I'm going to imply. Let's see what happens. I think it will pick up because of Paris. Is it doing anything? Or yeah, it is running. Oh, it is not. No, wait.
It might be below you. The answer might be below you already now.
Oh yeah, there it is.
How many?
Yeah. It is raining in Paris. Okay, good. What is the weather? It is raining.
You want them in order you put them in, right? And it put them in that
order.
order.
I see. Okay, got it. Okay. 106. Not bad.
It's in 3.
Yeah.
Well, wait. Is it raining in Paris? Is your question? So it's running the question against the question. I see.
Right,
That's why
right.
it's the highest. But it does put the what?
It ranked the 3 brothers last, right? So. Well, I mean, yeah, it works. Okay.
What kind of model are they using to do this with? I mean, what are they?
Oh, this is also this 3 things they had, and this still worked, right?
But the multiple comparison is written on top of the models, right? They're just using similarity in those 3 models.
Yes.
Okay.
If you select more than one, they're just going to run all of them and show you the results.
Yeah,
right?
get it.
So it's yeah.
It's not really like some re-ranking algorithm or something. It's just they're using similarity.
Right. Yeah.
For different.
Yeah. It's like this now. More data. Not bad.
And
I mean,
all the inference is done on CPU, I'm guessing.
Inference is all done on CPU. Yes.
CPU. Okay.
So it gets it's raining in Paris as the top one, right?
Mm-hmm. Yes.
Okay. Excellent.
So yeah. And then there is another one, which is search cluster, which let's look at this. How do I sort a data frame by? Okay, let's do that. I mean, that's not bad. Let's do all 3. No results. No, only 1. Okay. Give me my search. Oh, they send you to another one. Spaces Plotly integration demonstration is somewhere else.
Isn't the first demo we did and the second one just doing the exact same thing?
It's
just
doing
similarity
similar
between
things,
similarity between sentences versus similarity,
Yeah.
Are they doing something fundamentally different?
Well, it's a little different use case, I think, right? So this is, how relevant is the answer to the question? Kind of sentence similarity, but a little different spin. It's, more towards question answering, maybe towards filtering, pre-filtering answers to questions for question answering task.
But you're probably just, what I'm saying is they're just submitting similarity queries into the same model, and then I just don't see what they're doing different other than GUI.
Oh yeah, it's pretty much the same thing. Well, to that point, I mean, you can also say that our demo, the feature finder is doing very little different, right? I mean, it's instead of doing a image or text to image, it's doing text to patches basically, right? It's cutting up the image into patches and then doing a text to patches simultaneously with all the patches. So a little different, but we're still using the same underlying model. So.
Thank you. I have a hard stop today at pretty soon.
Yeah, me too. I have another meeting coming up right after this.
Yep.
So.
Okay. Yeah, we should. Anything else real quick before we call it quits?
Yeah, actually, don't share this chat, please. Because
okay.
it has a currently non-working URL.
Yeah.
Right. So
okay.
because this is private, people will get a 404 or 403 or whatever.
Yeah. Okay. I won't share anything.
Okay.
Actually, I have
all right, guys. We'll talk. Sorry. Go ahead,
really, really quick question. So we look at similarity as just in this like structures that we have, and there's a more general field doing similarity of ontologies. I looked at that before because that's what that's one of what standard ontology tasks is to try to do ontology mapping. Have you looked at it recently?
No, the only time we did this, the ontology mapping, it was a very, very manual thing in my last company. And it was handled by domain experts. And to be fair, they didn't even want us interfering. So, it was like, yeah.
I know there's a textbook on ontology I bought 6 years ago, or maybe longer now. I know the field you're talking about, but I don't know if they've updated that textbook into the. I mean, that's the idea, right? If you could take that tradition and find how it's evolving now with deep learning, right?
Yes.
So reason I'm asking is that somebody found a paper where they actually started doing, they started doing it with NLP, with embeddings. But it's really difficult to say whether it's somebody, everybody wants to try, this techniques, or is this a more or less a state of the art, or is it somebody trying? So that's what I'm trying to
I mean, I would guess, I don't know about that field, but I mean, this is obvious that, using ML, graph ML, I mean, basically you can put your ontologies into, vector space now, right? It's sparse data. You put it in vector space using SageGraph or one of those, and then that's how you can get similarity. So can you tweak similarity to be mapping? I'm just brainstorming right now.
Yeah, it's part of it. But by the way, another really, really quick question. So I asked about graph libraries before.
Mm-hmm.
What's a good graph visualization library that you can use on embed in the websites? And
iGraph is good.
GraphViz?
GraphViz I haven't used. I have used iGraph. iGraph is good. Yeah, it's medium-sized graphs you can handle pretty well.
All right.
Yeah.
Cool. Thank you.
Cool. All right.
All right, guys. Talk to you next week. Take it easy.
Okay. All right.